Greetings everyone. In this video, we will understand the approaches to claim whether a function is invertible or not, and further, if a function is invertible, we will find the inverse of that function. So, you already know that for a function to become invertible, it has to be a bijective function. So, let us quickly recall what invertible function looks like. Now see, suppose there is a mapping that goes from A to B and it is done like this. First of all, in order to claim that a function is invertible, you have to show that a function is bijective function. So you can easily see that this mapping is a bijective mapping, one onto mapping. Now what is this? This is a function f mapped from A to B, and suppose the function is fx is equal to y. Now the inverse of this function is a reverse mapping, means the mapping from B to A. In this case, your domain becomes B and codomain becomes A, and reverse mapping means inverse mapping is like this. Now look at this mapping. This f inverse is a mapping from B to A, and x is equal to f of f inverse y. Now what is this f inverse y? It is simply a function of y, g of gy, any function of y which is derived from this function. Now look at these two. This function is completely a reverse of this function. The mapping is in reverse order, means the domain has become the codomain and the codomain has become the domain. Now this is an inverse function. This is a pictorial representation. Now we will quickly look at some questions. If f is an invertible function defined as fx is equal to 3x minus 4 upon 5, find f inverse x. Now see, simply you have to find the inverse, and it is already given that f is an invertible function. So you need not to show that f is a bijective function, f is a one onto function. You need not show that. Simply start from fx is equal to y. See, one thing you have to be very clear of is you should not be eating any step, and you should not be adding any unnecessary step in your solution. Be very precise with your answers. So first of all, you will start with the function. So fx is equal to y is a function. It is defined as what? Fx is your 3x minus 4 upon 5 is equal to y, right? So what you have to do is simply find the function f, some function in the terms of y. Now keep on solving this. First of all, I'll do cross multiplication. It's 5y. Then it goes like your x is what? 5y plus 4 upon 3, right? Okay. So you started from the function of x, and now you are at a function of y. Means this is what? This is simply a function gy, or this is only the function f inverse y. Now what? You got your f inverse y is what? 5y plus 4 upon 3. Alright. So this is, you got the answer. But in the question, you see, they have asked you f inverse x. So you need not worry. Just simply change the variable. You know the function f inverse, right? Your main motto of finding the inverse of the function is already done. Now if they change the variable, you need not worry about that. If they have asked f inverse x, just simply write it in the terms of x, 5x plus 4 upon 3. And if they ask you f inverse 10, you can simply find f inverse 10, put x as 10. You can do this, right? So this is how you solve. Alright, so look at this question very carefully. This will probably solve all your queries about invertible functions. Now see, there is a function that goes from r plus, means positive real numbers, to minus 5 to infinity. Given by fx is equal to 9x square plus 6x minus 5, this function is given, and you are asked, show that f is an invertible function. Means you have to show that fx is a bijective function, means you have to prove 1 onto, and then you have to find f inverse y, then f inverse 10, and then if f inverse y is 4 by 3. So how you have to begin is simply by, first of all, you will start by proving that f is an invertible function. How? So let us begin. First of all, we will prove it's a 1 function. For 1 you know what you have to do. You just have to do f of x1 is equal to f of x2, right? That means, see, all these signs are very important, so do not forget to put them. 9x1 square plus 6x1 minus 5 is equal to 9x2 square plus 6x2 minus 5. So you can simply cancel out minus. Now further bring everything this side. That means 9x1 square minus x2 square plus 6 times x1 minus x2 is equal to 0, right? So what this means, 9x1 plus x2, your a square minus b square is equal to a plus b, a minus b, right? Minus x2 plus 6x1 minus x2 is equal to 0. Simply what? You take x1 minus x2 common. It's 9x1 plus x2 plus 6 times 6 only is equal to 0, right? So now see, you have two choices. Either this is equal to 0 or this is equal to 0. Now you know this cannot be equal to 0, right? This cannot be equal to 0. But why? Because x1 and x2, your x1 and x2 belong to positive real numbers, right? So this entire entity is positive in nature, right? Greater than 0. Greater than 0. So this cannot be equal to 0. So we will treat this as 0. x1 is equal x1 minus x2 is equal to 0. That means x1 is equal to x2. Therefore fx is 1 1, right? Now for onto, you know, you have what for onto, what you have to show is that every element y has a pre-image in x in the domain, right? Means what? Let for onto, let fx is equal to y. This means what? 9x square plus 6x minus 5 is equal to y. Now you have to find y x in terms of y, right? So simply bring y this side and apply your Sridharacharya formula, if you remember that. So what is it going to be? X is equal to what? Minus b means minus x plus minus under root b square minus 4a, and c is what? C is your minus 5 minus y, right? Upon 2a also. 2a means 2 times a, 9 to 18, yes. So your x becomes minus 6 plus minus 9, 36, 36 6 under root 1, और ये minus minus cancel, 1 plus 5 minus plus y upon 18, right? So your x is minus 1 plus minus under root 6 plus y upon 3, right? This is your x, or it can be written as under root 6 plus y minus 1 upon 3, right? So you got what? For all y belonging to your, what is the y codomain? Minus 5 infinity. For all y belonging to this codomain, there exists some x, there exists x belonging to your domain R plus, such that f of x is equal to f of y. This is how you claim onto. For all y belonging to the codomain, there exists x belonging to the domain such that fx is equal to y. Means every y has a pre-image in the domain. Now x is equal to under root 6 plus y minus 1 whole upon 3. So you know f inverse is a mapping from minus 5 to minus 5 comma infinity to r plus. You know, in inverse your codomain becomes the domain, right? So you write it in reverse order, where f inverse y is what? X, right? So what is your f inverse y? It's simply under root 6 plus y minus 1 upon 3. Alright. So further the question has asked you to find the value of inverse at 10. F inverse 10 is what? Simply put 10 in the place of y. Under root 6 plus 10 minus 1 upon 3 means what? 16. 16 means 4. 4 minus 1, 3 by 3 means 1. Your f inverse 10 is 1. And then find the value of y if f inverse y is 4 by 3. Alright. So this is your one part, this is your another part, this is your third part. F inverse y is 4 by 3 means under root 6 plus y minus 1 upon 3 is equal to 4 by 3. So first of all cancel 3 by 3, you will get under root 6 plus y minus 1 is equal to 4. This gives you under root 6 plus y is equal to 5. Further do whole square both the sides. You will get 6 plus y is equal to 25. Therefore y is equal to 25 minus 6, which means 19, right? So these kinds of questions possibly come in 6 marks category. And what you do, simply show that the function is 1 1 onto, that means the function is invertible, and from onto you will get a value of x, which is itself the inverse function. Alright, so this was all about inverse of a function, and I hope you have understood. In other cases you can reach out to me. Thank you.